All right. On your notes, you're going to write double angle formula. Double angle formula. Hold on, I'm getting my notes out. All right, double angle formulas. All right, so on your green sheet, we're looking down here at these ones. And if you guys notice, sine only has one. Cos has 3. All 3 of them are good. You can use whichever one you want. And then tangent only has 1. Okay? Yeah. So when you have a double angle with cos, you can make it in terms of sine and cos, or just sine or just cos. As you can imagine, that might come in handy with proofs, right? Okay. All right, so on our sheet, we are going to do an example problem of this. We're going to find sine. Hold on, I'm going to write it in radians. Sine of 10 pi thirds, cos of 10 pi thirds, and tan of 10 pi thirds.
Is there any work I'm missing in 4th grade that I can get?
No, Braden, you're not interrupting. It's cool.
I'm just trying to get my work done. Hey, Braden. Yeah, man. Thank you.
All right. All right, we're moving on. So what we want to do is we want to rewrite the problem. We're doing it 3 different ways. We want to rewrite the problem so that we're saying sine is 2 times something, and that 2 times something equals 10 pi thirds. It'd be 5 pi over 3. Okay? So, and this is because we're using a double angle formula. So if I double the angle 5 pi thirds, then I get 10 pi thirds. Does that make sense? Okay? So if you remember from last time on Friday, we were looking at like, oh, we need 2 angles that add up to be the angle that we wanted. Here we need an angle where if we do 2 times that angle, we get the angle that we want. So 10 pi thirds, I need to do 2 times 5 pi thirds, and that will get me to the 10 pi thirds. Does that make sense? Okay? So 5 pi thirds is on our unit circle. That's a good sign. Sine of 2 theta. I'm going to go ahead and write the formula. Sine of 2 theta is 2 sine theta cos theta. All right. So to find sine of 10 pi thirds, we're going to do 2 times 5 pi thirds. Okay? So that means that sine of 2 times 5 pi thirds is 2 times sine of 5 pi thirds times cos of 5 pi thirds. And this is where we look at the unit circle to see what sine of 5 pi thirds is. Negative root 3 over 2 times cos of 5 pi thirds. It's not negative root 3 over 2. 1/2. All right, and then if we simplify this, well, we've got a 2 that can cancel, right? Multiply by 2, divide by 2, that can cancel. And then we're going to multiply straight across. So we've got negative root 3 over 2. And that is it. So if we want to check our answers, we're using the sign button in this problem. So that means that to check our answers, we have to be in the mode radians, because our problem is in radians. I'm going to type in sine of 10 pi divided by 3. And then I get negative square root of 3 divided by 2 is what we got for our answer. And if you check those decimals, they match, which is how we know we got it right. All right, how do we feel about that one? Formula's okay? All right. Next, we're going to do the same thing, but for cos. So second, we're going to say that this is cos of 2 times 5 pi thirds, right? Now, the difference with cos is that you do have 3 options. So which option would you guys like to practice?
First one.
The first one, cos squared minus sine squared?
Number 2.
The third one. Well, are we going to do all of them?
Nope, we're just going to do one of them.
How do you pick your favorite, Miss Rice?
They're all the second one. We're going to do the second one. All right. All right. So we're going to do the formula that says cos 2 theta equals 2 times cos squared minus 1. That's the one we're going to go ahead and use. All right. Can somebody remind me what this notation really means? The two right there. It really means cos theta is being squared. That's what it actually means. Okay. It's important for us to know that because we can't plug something in if we don't understand how it works, right?
I thought you were talking about more complicated.
No, no. I wasn't saying we should replace it with something else. I was just saying like making sure that it makes sense. Okay. So we have cos of 2 times 5 pi thirds, and then we'll go ahead and plug it into the formula. So that's 2 times cos of 5 pi thirds squared minus 1. And we already did the work. We already know what cos of 5 pi thirds is. What was it? You remember? It was 1/2. Okay. So that means we have 2 times 1/2 squared minus 1. So that's 1/4. So we have 2 times 1/4 minus 1. Yeah, that's 2/4, which is 1/2. We have 1/2 minus 1, which is negative 1/2. Okay. So if we want to double check our answer for that, just to make sure that we did all the math right, I was trying to find cos of 10 pi thirds. I got the answer negative 1/2. I'll go ahead and type it in and make sure my decimals match, and they do. Oh, yeah. All right, the third one, yeah. The cos was gone because we said cos of 5 pi thirds is 1/2. That's the point when the cos went away. Yeah. Okay. So next we're going to do the same angle, but we're going to talk about tan. So this time it's going to be tan of 2 times 5 pi thirds. And just like with sine, tan only gives you one option. And just like before, the tan option is not the fun one. So tan of 2 theta equals 2 tan theta. Yeah.
Is there any way we could have done the previous answers for the sine answer divided by the cos answer?
To get the tan answer?
Yes. Is there any way we could have done negative root 3 over 2?
You'd have to check. You'd have to do like a proof
Oh, yeah.
to see if
But, like, short
tan.
answer is not like the way to do it.
Actually, yeah. Yes. Yeah. Yes. Because tan 2 theta would be the same as sine 2 theta divided by cosine 2 theta.
Yeah.
So yes.
So, like, even though we have to do proofs, we wouldn't technically have to do this.
No, technically. Well,
I know. We
yeah.
already do proofs,
So
but we already know the answer.
so if I gave you a tan problem on its own, then it might be shorter to just do the tan problem. But if you had already done the sine and cosine problems and you wanted to just do sine divided by cos and get your answer, then that'd be fine. Yeah. All right. So we're going to go ahead and do this as tan of 2 times 5 pi thirds equals 2 times tan of 5 pi thirds divided by 1 minus tan of 5 pi thirds, and I'm going to go ahead and write the squared on the outside, just so that I know when I put it in that it makes sense. Okay. So 5 pi thirds is right 1/2 and down root 3 over 2, right? So tan of 5 pi thirds would be what? Negative
square root 3.
just negative square root 3. So it could have been worse, right? It could have been worse. All right, so that gives us 2 times the square root of 3, negative square root of 3, divided by negative square root of 3 squared. Okay? So on the top, we have 2 times negative square root of 3. Negative 2 square root of 3 divided by 1 minus. So a negative squared would be a positive, we know that. What's the square root of 3 squared? It's just 3. It's just 3, right? Square root of 3 squared would be 3.
Oh, yeah.
So 1 minus 3 is negative 2. So we have negative 2 square root 3 over negative 2. The negative 2's cancel, and we just get square root 3. Okay? And then we can go ahead and double check that we got it right by doing tan of 10 pi thirds and checking the square root of 3. And our decimals match, so we're good. Okay. Can I show you the part of this that makes it really stupid? All right. All right, so we were looking at 10 pi thirds. 10 pi thirds is bigger than 2 pi, so it's not on the unit circle. But what happens if we find a coterminal angle? How do we find a coterminal angle for 10 pi thirds? Subtract. So we're going to do 10 thirds, and we're going to subtract off 2, and that's actually 4 pi thirds. Is 4 pi thirds on the unit circle? Yes. Yes, it is. So this is saying it's coterminal of 4 pi thirds. Is it true that the y coordinate of 4 pi thirds is negative root 2 over, or negative root 3 over 2? Is it true that the x coordinate of 4 pi thirds is negative 1/2? And is it true that tan at 4 pi thirds would be just positive root 3? Okay. The part in my brain as a teacher that makes me really mad about the double angle formula is the double angle formula only works for numbers that are already on the unit circle.
What are you trying to say here?
I'm saying that I have to teach it to you, and you have to do it. But it's frustrating because I'll basically say, like, use the double angle formula to find sine of 300. And you're like, Ms. Rice, can I just look at sine of 300? And I say, no. You have to do 2 times 150. Or I'll say, use the double angle formula to find cos of 30, or of 60. You'll be like, Ms. Rice, can I just look at 60? No. You have to do 2 times 30. We're doing it the hard way on purpose because you have to learn the formula. I don't like this formula because I think it's silly because you could just look at the unit circle to find the numbers already. Also, who in the world is listening to music right now? So we're turning it off. All right. And headphones out? We're all out? If you don't show your work, you get in trouble and you don't get credit because I need to see that you can use these formulas. Do I think it's stupid just like you do? Yes, I clearly think it's stupid. However, now what I will say though is that these are good practice because these double angle formulas do show up in proofs a lot. For instance, the cos 2 theta, my calculus students this unit have used these 3 formulas more than anything else. They have repeatedly used these 3 formulas to do stuff in calculus. None of them remembered it. I had to make them a sheet and they keep forgetting to look at it. But the double angle formulas, they do show up, they just don't typically show up with evaluating. And that's because if you're going to evaluate something that's on unit circle, you're just going to look at the unit circle and call it good. Does that make sense? Yeah. Okay. Do you have to practice it? Yes. Do you have to show your work so that I can see you know how to do it? Yes. But is it nice because you can go and check your answers? That's kind of nice. I don't know. Because you know when you do these that your answer should be root 3 over 2, root 2 over 2, 1 over 2, and then like root 3 over 3. You know what I'm saying? Like you already know what your answer should be, so it's pretty easy to get the answer right. Does that make sense? Yes.
Do you have to remember these, or are you going to give it to
These are one of the ones that you do not have to memorize. I will give them to you on the test. Okay. All right. So those are the silly ones. I'm going to go ahead and write that mental note at the bottom. All of the double angles only work for angles that are on the unit circle anyway. Hashtag it's stupid, I know.
I am telling the superintendent.
Don't do it.
Do it.
What hashtag do that?
All right.
I dare you to do that.
There's all the double angles. Okay? So how do we feel as far as being able to plug things into the formulas? We're okay with that? So the things that you plug in, they always come from the unit circle just like they did on Friday. Okay? And then you just have to understand what the formula is saying so that you can square things or whatever correctly. Right? Okay, we're going to do half angles. These ones I actually like because you need the formula.
This is another one?
Thank you. I try. They are shiny. They're like iridescent.
Yeah, they are.
Ooh. All right. Alrighty. Okay, for this example, we are going to find sine of 3 pi eighths, cos of 3 pi eighths, and tan of 3 pi eighths. Okay, we're going to find sine, cos, and tan, all of 3 pi eighths. So this one is going to feel a little bit less stupid because these numbers are actually numbers that are not and cannot possibly be on the unit circle. Okay, I could do a half angle formula of 60, right? Half of 60 is 30. So I could use a half angle formula to find something on the unit circle. But typically the half angle formulas are going to be like, tell me the exact value of 22.5 degrees. You're like, 22.5 degrees is not on the unit circle, but 45 divided in half is 22.5. Does that make sense? Or if I wanted you to find something of 15 degrees, 15 degrees is not on the unit circle, but if you use sine of 30 and a half angle formula, then you can find it. Does that make sense? Okay. So these are actually going to come in handy sometimes when we're working with a number that truly is not on the unit circle, which is why I like these better. Now, one thing you need to look at on your green sheet is what shows up in front of all these formulas. A plus or minus. It does not mean that there are two answers. Did you hear that? It does not mean that there are two answers. It means that whenever you do these problems, oh, these do not have a plus minus. whenever you do these problems, you have to think about all students talk constantly. You have to remember which quadrant you're in, and you have to choose if it's the plus version or the minus version. Okay? You choose it based on which quadrant you're in and if your answer should be positive or negative. Does that make sense? Yes.
Yes, did you say Eleanor Macadam's finance?
Yes. Bye, Miss Macadam. Here's your assignment.
Yay.
All right. You will notice that tangent has 3 options. You guys see that? Tangent has 3 options. We are typically going to use the 3rd option because it is the easiest one. We are going to ignore these 2 because they're not as easy. Okay? All right. So here we go. We have to figure out what angle you can divide in half. What angle would divide in half to give you 3 pi 8ths?
6/16.
6/16 is the same thing as 3/8.
Oh, I thought that's what you just said.
No, I'm saying we're dividing it in half. What angle would divide in 6/16 is exactly the same as 3/8. It's just not simplified yet. So I'm saying what angle could you divide by 2 and get 3/8? Say it again? 3/4. If you took 3 pi 4ths and you divided it by 2, then it would be like, oh, the 4 and the 2 make an 8. Or you could keep change flip, right? That's 2 over 1. And so dividing it by 2 would be like multiplying it by 1/2, and you get 3/8, right? If that did not go well with your brain, you can get your calculator out, and you can say 3/8 times 180 is 67.5 degrees. Is 67.5 degrees on a unit circle? Nope. So I'm going to multiply that by 2. So if I take 135 degrees and divide it in half, that's how I'm going to get my answer. Does that make sense? So 3 pi 4ths is 135 degrees. 135 degrees divided by 2 is what's going to give us our answer. Okay? So when we think of this problem, the first version is going to be sine of 135 degrees divided by 2, also known as sine 3 pi 4ths divided by 2. Whichever way you choose to think of it is fine. Okay? So 135 degrees divided by 2, 3 pi 4ths divided by 2. Okay? All right, which quadrant does 67.5 degrees fall in? Quadrant 1. So I'm going to go ahead and draw this on a picture. 67.5 degrees would be about here, right? That is quadrant 1. Should sine be positive or negative in quadrant 1? Positive. Okay. So I'm going to go ahead and I'm going to write out this formula. So it says sine of a divided by 2 equals plus minus, and then it has the square root of 1 minus cos A divided by 2. That's the formula, right? If you look at your green sheet.
Is that a 9 over 2?
It's not an alpha. I think that's actually... Oh, that was an alpha. Yeah, we should be writing alpha. Okay, so I'm going to start working out the problem using the correct notation. So I have sine of 3 pi 4ths divided by 2. I'm doing the positive version of plus minus because this is a first quadrant angle. 67.5 degrees shows up in the first quadrant. So that means we're going to have a positive answer. Underneath the square root sign, I have 1 minus cos of 3 pi 4ths divided by 2. All right. What is cos of 3 pi 4ths? Yep. root 2 over 2. Positive or negative?
Negative.
Negative. Alright, so we're going to have 1 minus negative root 2 over 2, all divided by 2. We have a 1, and we have a fraction. Common denominator, okay? So I'm going to take that 1, and instead of leaving it as a 1, how am I going to write it?
2 over 2.
2 over 2. Okay. So on the top of the fraction, what happens with this minus minus? Plus, right? Minus minus makes a plus. So we have 2 plus root 2 over 2, right? That's the top. And then we are still dividing by 2. Can you see that? Okay. We have this 2 right here. If I was to write this 2 right here as a fraction, how would I write it? Over 1. So I'm going to do keep it, change it, flip it. Keep the top, change it to a multiplication problem, and flip this one up. So I'm going to say times 1 over 2. If you cancel these two 2's, you kill a cow. So that gives us 2 plus square root 2 over 4. That's it. I'm going to let you guys leave it like that. 2 plus square root 2 over 4, all underneath a square root sign. It looks terrible, but it's right. Okay? It would have been written as 2 plus square root 2 over 2, because you take the square root and you write it only over the top and only over the bottom. It's only one extra step. If you guys want to take it to that and write it that way, that's fine. But I'm okay with you leaving it underneath the square root. Okay. This is what I was talking about on Friday, where I said I talked to my friend who was a college professor, and that college professors don't care if you simplify things all the way. So this is the type of problem where, like, yeah, you can keep going, but you don't necessarily need to. Okay, so we're still going to double check and make sure that we can get these answers right in our calculator. So I'm going to double check sine of 3 pi eighths, and then I'm going to do a big square root sign with a fraction inside. That's 2 plus square root 2 over 4. And my decimals match, so I know I did it correctly. Alright, does that make sense? Okay. So, we're going to go ahead and do the cos version. So, we're doing cos of 135 degrees over 2, or you can think of that as cos of 3 pi fourths over 2. And the formula for cos is cos of alpha over 2 equals plus or minus square root of 1 plus cos alpha over 2. You guys notice how similar those formulas are? Yeah. The sine version had a negative, the cos version had a positive. That was the only difference between the forms. So what you'll notice is that as we go about plugging this number in, the process is almost identical. We're going to do almost the exact same thing we just did. Okay? So if we think about where 67.5 degrees shows up, or where 3 pi eighths shows up, it would show up here in the first quadrant. And what do we know about cos in the first quadrant? It's positive. So that means we're going to be doing the positive version of 1 plus cos of 3 pi fourths, all divided by 2. You got it, Corday? It's like sinking in while you're sleeping. Your eyes are closed, but it's like getting in. All right, so we've got 1 plus, what is cos of 3 pi fourths? It's negative root 2 over 2. Over 2. All right. All right, and this is going to feel very similar to the last problem. What should we do next? Take the 1, and we're going to get a common denominator. So I'm going to write it as 2 over 2. Say it again? Yes, they're very repetitive. So on the top, what do we have?
2 over 2 plus.
So we've got 2 minus root 2 over that common denominator, all over 2. And this 2 on the bottom is really what? It's really 2 over 1.
Okay.
So it's really a 1/2 that we can flip up here, right?
Yeah.
Okay. Yep, so it means we've got 2 minus square root of 2, all divided by 2 times 2 is 4. So you can write it like that. Or if you want to take it the final step and say that this is what you have, that's fine as well. Okay? All right. Are we good with that part?
Yeah.
And we do want to do tangent. We are almost done. So tan of alpha over 2. We had 3 options. We're going to go ahead and use the last one. You need to pick that up. All right. So here we're going to have tan of 3 pi fourths divided by 2 is 1 minus cos of 3 pi fourths divided by sine of 3 pi fourths. So what do we have on the top? It's square root 2 over 2, right? But it's negative, so we have 1 minus negative root 2 over 2 over sine of 3 pi fourths is root 2 over 2. Okay? What does that minus minus do? Makes a plus. Okay? What do we do with the 1? We make it a 2 over 2 so that it has that common denominator. So on the top, what do we have?
2 plus 2.
We have 2 plus root 2 over 2. And then the bottom hasn't changed at all, right? That's just root 2 over 2. And what do we do with the bottom? You can flip it up. So then we're going to have 2 on the top and root 2 on the bottom, and these two things are multiplying. You're not actually going to multiply them. What do you guys see? Yeah, those 2's can cancel. Yep, so we're going to say that we have 2 plus root 2 on the top and root 2 on the bottom, and that's going to be our final answer. Yes, you could simplify that, but you don't necessarily need to. And so we're going to go ahead and leave it there. Okay. So again, we can go ahead and check this. We know that tangent is positive in the first quadrant, so we know that if we were to have done this formula, we would have done the plus version. The nice thing about the other 2 tangent formulas, and the one that I'm telling you should probably use because it's easier to use, the nice thing about this is if the answer is positive, it will just work out to be positive, and if the answer is negative, it will just work out to be negative, and you don't have to worry about it. Okay, the only ones you truly have to worry about are the sine and cosine ones. But if we want to go back and double check our answer, we should type in tan of 3 pi eighths. And then we can type in 2 plus square root 2 divided by square root 2, and you can see that the answers match. Alright? Okay, any questions on those?